Good day, young scientist. It's a brand new day again here in my science class, and I'm Sir Paulo A. Rivera, your science teacher for today. I'm so excited that you are with me to learn new concepts, skills, and competencies in science. Make sure that you are in a comfortable place so that you understand and you hear me loud and clear. So let's start. Hello, class. Welcome again to our session for this morning. And what I have here is something about with the energy. All right. So to talk about with energy is simply defined as the ability or capacity to do work. And to give you a simple activity for this session, so may I ask everyone here what would be the difference between the group letter A and for the group letter B? Aha, very good. For our group letter A, we noticed here that all of the persons here are moving, while for the group letter B, all of the objects here are in at rest. So, in relation with our discussion for this session, we will talk about the types of energy, that is the kinetic energy and the potential energy. So to begin with, let's start with the kinetic energy. But what is a kinetic energy? Kinetic energy is a form of energy that an object or particle has by a reason of its motion. Or simply, when we talk about energy, it is an energy in motion that always depends on its mass and the speed. And usually or always remember that this kinetic energy is measured in joules or capital letter J, that is also the same with the unit for the work. That is our previous topic. And also, be familiar with the symbol of its kinetic energy, that is for a capital letter K and a capital letter E. So for some application of this kinetic energy, always remember that any object that is moving, they possess the kinetic energy, like walking, running, rolling objects, running water, and a flying object. Okay, and also, here for kinetic energy, we will have here a formula. For us to be able to get for the value of kinetic energy, we need to follow this formula. Ke is equals to 1 half mv squared, wherein Ke stands for kinetic energy that is always expressed capital letter J or in joules. M stands for mass that is always expressed in kilograms. V is for velocity that is always expressed in meter per second. Right. So now, since we have now an idea about the formula for kinetic energy, so now let's try to apply kinetic energy in a sample problem. So let's start with sample problem number 1. For sample problem number 1, what is the kinetic energy of a car that is moving with a mass of 1,500 kg with a speed of 10 meter per second? So the same with the other topic that we already discussed, we will first get all the given values on our sample problem. So first, on our problem, we will have 1,500 kg. So since it is in kilogram, meaning it is the value for our mass. And also we have here 10 meter per seconds, that is our velocity. And for the Ke, that would be our missing value here. So now, after we get all the given values on our sample problem number 1, so now we will proceed with our correct formula. So the formula for our kinetic energy, that is Ke, is equals to 1 half mv squared. After that, let's substitute all the given values on our sample problem number 1. Ke is equals to 1 half multiplied by the 1,500 kilogram multiplied by 10 meter per second squared. So first, before you get the product of this kinetic energy, so first, all you have to do is to get the squared of this velocity, which is the 10 meters squared. So the 10 meter per second squared is equivalent to 100 meter per second squared. So meaning to say this would be our new value for our velocity. So after we get the squared, so let's proceed with KE is equals to 1 half multiplied by 1,500 kilogram multiplied by 100 meter per seconds. So after we get the product of 1,500 kilogram and 100 meter per second, so now let's get the half of the product of this. So 1,500 multiplied by 100, that is equivalent to 150,000. Wherein the half of 150,000, that is equivalent to 75,000 joules. Alright. So now, let's have another problem or sample problem number 2. So a sports car is moving at 4 meter per second. If the mass of the car is 800 kilogram, how much kinetic energy does it have? So since we have known the problem, so let's analyze first what would be the question. The question here is how much kinetic energy does it have? Meaning to say, the missing value here is our kinetic energy. So first, again, let's get all the given values on our sample problem. Mass is 800 kilogram. Velocity is 4 meter per second. And still, our missing value is for kinetic energy. After we get all the given values, so now let's get the correct formula. The correct formula for our kinetic energy is AE is equals to 1 half multiplied by mp and squared, or KE is equals to 1 half mp squared. So after that, let's substitute all the given values. KE is equals to 1 half multiplied by 800 kilogram multiplied by 4 meter per second in squared. So again, before we proceed with our product of the mass and velocity, let's get the squared of this 4 meter per second, that is equivalent to 60 meter per second. And after that, that will be the time that we need to multiply 800 kilogram to 60 meter per second. So after that, 800 multiplied by 60, that is equivalent to 12,800. So since we have here the 1 half, let's divide 800 kilogram and 16 meter per second, that is 12,800. That's divided into, that is equivalent to 6,400 joules, or capital letter J. So that would be the final answer for sample problem number 2. So now, for our sample problem number 3, that would be your exercise. So now, I will post here the question, and what you need to do is to answer the sample problem number 3 for at least 1 minute. So the question is, what is the kinetic energy of a 60 kilogram girl on skis traveling at 20 meter per second? Alright, so I will give you 1 minute for you to be able to answer this problem, and your timer starts now. Alright, time's up. So now let's check your work. Alright, so let's check if your answers are correct. So for our sample problem number 3, what is the kinetic energy of a 60 kilogram girl on skis traveling at 20 meter per second? So the question will be, what is the kinetic energy? So still, the kinetic energy is the missing value here for sample problem number 3. So the same with the process of the sample number problem number 1 and sample problem number 2. First, let's get all the given values. So our mass is 60 kilograms. Velocity is 20 meter per second, and still our missing value is for kinetic energy. And after we get all the given values, so now let's proceed with the correct formula. So the correct formula is KE is equals to 1 half mv squared. After we get all the given values or the correct formula, so now let's proceed with the substitution of our given values. KE is equals to 1 half multiplied by 60 kilogram multiplied by 20 meter per seconds and squared. So again, let's get the squared of 20 meter per seconds, that is equivalent to 400 meter per seconds, multiplied by 60 kilogram, that would be for a total of 24,000. So after we get the 24,000, let's get the half of this 24,000, that is equivalent to 12,000 joules. Alright, so hoping you get the correct answer for this sample problem number 3. Alright, so after you accomplish or finish your practice, so I will give you an homework that is also related with kinetic energy with these 2 questions. So for question number 1, a roller coaster with a mass of 2,000 kilograms is rolling down a track with a speed of 10 meter per second. So the question is, what is its kinetic energy? For question number 2, what is the kinetic energy of a car with a mass of 2,000 kilograms moving at 30 meter per second? Alright, so I will wait your answer on our comment section, and after that, hoping that you learn something from this lesson. And thank you for today, and always remember, stay curious. Bye!